All right, so the next concept that we want to discuss is displacement. Displacement is defined as being the straight line distance from a beginning point to an end point. So you can see in the picture of this ant, the ant starts out at the anthill and then walks along this dashed purple line. The length of the dashed purple line would be equal to the ant's journey's path length, but we want to know what is the displacement. What is the straight line distance from the beginning point to where the ant ends up? You'll notice something interesting about displacements. If we consider the ant's halfway point along its journey, the distance from the anthill to the halfway point would be this dB distance, and then the displacement from the halfway point to the ant's final point would be the length of this second arrow, dc. Now, if we add together the length of this first displacement to the length of the second displacement, we would actually get something longer than the displacement distance for the entire journey. So that means we have to add together the displacements as vectors in order to get the correct answer. But what does that mean? How do we do that? How do we add displacements at vectors? And what are these vector things anyway? So a vector is a vector is used to describe a quantity that has both magnitude and direction. So it's different from something that is a scalar. A scalar is a quantity that is a magnitude or has a number associated with it only. So for example, the number of apples in a basket would be a scalar. Your age would be a scalar, and speed is a scalar. It only has a magnitude or an amount. Now, scalars can be both positive or negative. In a way, your age would be negative if you were considering a time before you were born. On the other hand, vectors have both a magnitude and a direction. So these are things such as displacement, which is that straight line distance from the beginning to the end point, and we'll see how velocity and acceleration are also vectors. Velocity in physics is different from speed because we consider both the magnitude and the direction of that the object is traveling in. So these vector things have both a direction and an amount, and we usually write them as arrows. So we use arrows to show the size of a vector and also the direction that the vector is pointing. So the length of the vector, its magnitude, corresponds to the amount, and then the direction is indicated by the direction that the arrow is pointing. So some properties of vectors that are important to know. One property is that two vectors are equal if they have the same magnitude and direction. So if we look at this picture here in the top right-hand corner, all of the vectors in this picture are equal because they all have the same length and they are pointing in the same direction. Now this is very useful because it means that we can take a vector and slide it all around. It doesn't matter where we put it. The only things that are important in regards to a vector are its length and its direction. Now we can take the negative of a vector, and that means that we have a second vector that has the same magnitude but is pointing in the opposite direction. So if this is vector A, we can get the negative of A just by flipping the direction of the vector but keeping its magnitude the same, keeping its length the same. Now when we need to add vectors, like we saw with our ant example, what we use is a method called tip to tail. So we take the first vector and then we place the second vector, because remember we can slide vectors around. It doesn't matter where they are located, only the length and direction are important. So we can slide the second vector around so that its tail is on the tip of the first vector. Then we can draw a vector that represents the addition of those two vectors going from the tail of the first vector to the tip of the second vector. Now, the order in which we add vectors does not matter. We could just as easily have taken vector B and then placed vector A so that its tail was at the tip of vector B, and then drawn the resultant as being from the tail of vector B to the tip of vector A. We can also use this method to add multiple vectors. So let's say we had 4 different vectors, A, B, C, and D. You can see the approach to adding them is that for each vector we take its tip and put it on the tail, or we take the tail of the vector and put it on the tip of the previous vector and continue along until we've added all the vectors together, and then the resultant goes from the tail of the first to the tip of the last vector. If we want to subtract a vector, subtraction works by adding the negative of the vector being subtracted. So let's say we had a vector A and a vector B, and we wanted to subtract B from A. Then what we do is we first take the negative of B. So remember, the negative is a vector of the same length but just pointing in the opposite direction. And then we add that negative vector to the first vector. So the resultant would look something like this. Another thing we can do to vectors is we can multiply or divide them by a scalar, by an ordinary number. If you multiply or divide by a scalar, the direction of the vector does not change, but its magnitude does. So for example, if I have vector A, 2A would be a vector that points in the same exact direction but is twice as long. A over 2, or 1/2 A, would point in the same direction as the original vector but be half as long. And finally, if I multiplied A by -2, that means I first take the negative of A, that means flipping it to the opposite direction, and then doubling its length.